So in this unit, we are going to start talking about forces, and we're going to get into Isaac Newton and his three laws of motion and how all of those things affect everything that goes on around us. So at the end of this lesson, you should be able to recall Newton's first law and also recognize situations in which Newton's first law applies. In your notes, you need to make sure that you have Newton's first law, not just the words that we're going to talk about being Newton's first law, but also make sure that you understand it. So you're going to need to write it in your own words. Then you're also going to need to describe a situation not shown in the video that exhibits Newton's first law. So take a minute and look through these situations. Can you predict what will happen in each one? In this first scenario, there are clothes lying on the floor of your room. What will they do? Probably just lie there, unless you come along and pick them up. What about a bowling ball rolling across the gym floor? Bowling balls roll really easily. That ball will just keep on going, right? When will it stop? Barring any other interference, the ball will keep going on a straight line until it hits a wall. Now say you hit a tennis ball. That ball is going to fly through the air. Not in a straight line forever, though. It gets pulled down to the ground. And what horrible thing happens if you forget your Sonic cup on the top of your car? Your cup tries to stay where it was as the car drives out from underneath it. Have you ever been in a car that has suddenly stopped? What happens to you? Your body tries to keep going in the same direction you were traveling in. The same thing happens if your car takes a hard turn. You get thrown against the door. Or do you? You might think of it as just your body wanting to keep traveling along in its original path. So in all of these scenarios, what we're really saying is that the objects at rest will stay at rest, and the moving objects will stay moving, and they also resist changing their motion. This is Newton's first law of motion. You've probably heard it before. An object at rest will stay at rest. An object in motion will stay in motion unless acted upon by an outside force. Let's take a second and clarify a couple things here. The object at rest is fairly straightforward. Look around the room. There are dozens of things at rest, and they aren't going to move. There are things in here that have not moved since I came in this room a few years ago. I just haven't applied the force to move them. Now let's look at the object in motion. The key idea here is that the object's motion will not change. So it's not just in motion, but the object will continue on in the same motion. Think about you as you are traveling along in the car. When the car comes to a sudden stop, your body wants to keep moving forward. Seatbelts are put in vehicles to make sure that you do not continue on forward and slam into the dashboard or go through the windshield. Now, this is also known as the law of inertia. Inertia is such a fun word. It is the tendency of an object to keep doing what it is already doing. So all of these things around you that are not moving, they are going to keep not moving. If you were to come along and try and move these objects, some of them would move easily and some of them would move more difficultly. Is that a word? So objects with a lot of mass have a lot of inertia, and they will be more likely to keep doing what they are already doing. For example, it will be easier to get your lawnmower moving than it would be a car, since the lawnmower is smaller and has less mass. So the car has more inertia than the lawnmower. Now, what is going on here? Say you have a truck and a car traveling along at the same speed. Which one is going to be harder to stop? The truck has quite a bit more mass than the van, so it has more inertia. it is going to be more difficult to get the truck to a stop than it is the van. So the truck has more inertia than the van. This is one of my favorite videos. What's happening here? The guy on the skateboard is moving along with the skateboard, and they're going at the same speed. And the skateboard comes to a sudden stop. The guy with his inertia goes on and keeps doing what he was already doing. So this is a really good example of Newton's first law. An object in motion will stay in motion unless there's an outside force acting on it. Now let's see if we can identify some examples of inertia as you're driving through town in your car. What are the 3 times during your journey that you would notice your inertia? Pause the video and see what you come up with. So the first thing you might notice is when your car starts to move forward. What does this feel like? It kind of feels like you were being pushed backwards into the seat. But what is really happening here? You and the car are both at rest. The car starts to move forward, but your body is trying to stay at rest. The car has to push you from behind to get you moving and overcome your inertia. The same thing happens when the car comes to a stop. You are both moving forward. The car comes to a stop and you want to keep moving forward. Finally, you might notice your inertia when the car is turning a corner. Again, you are both moving forward together. The car makes the turn and your body wants to keep moving forward in the direction you were initially traveling. It feels like you are being thrown against the door when in reality, you are simply trying to keep going forward as the car is turning. All right, how are we looking here? Can you recall Newton's first law? And do you think you can recognize and describe situations in Newton's first law applies? Make sure these are the ideas that you have written in your notes.